Yum, yum!
Hey, this is Ed Ferrari, and in this video we're going to create a wood screw using the new Mesh Fusion and some of the new procedural mesh operations introduced in MODO 10.2. So I have this mesh item here called screw_main, and this is going to be the main body of our screw. Now obviously it doesn't have the threading yet, and we're going to build that using the procedural system, but it's basically just a cylinder with a tapered bottom that kind of tapers to a point, and then it has this top that flares to give us this kind of bugle form. Now the top of this mesh item is going to fuse to this other mesh item, which is called screw_head, and this is just the Q-hex cubic that comes with Mesh Fusion. So if I come over to the Fusion V tab and click on cubic geometry, in the cubic preset browser, here it is right here, the Q-hex. So I just kind of adjusted that to make it a little bit shorter. Now I also have this mesh item called cross trim, and this is going to be a subtractive element. We're going to trim away this cross form out of this screw head form. And that will just give us the negative shape, which will be essentially what a screwdriver would fit into on the screw. And then also we have this sphere trim mesh item, and this is another trim, but it's not really a subtractive element so much as it is an intersect element. And it's just going to kind of trim away the top of this screw_head mesh item to give it kind of a rounded top. So before I actually start fusing, we have a little bit of work to do in terms of creating the threading. And we're going to do that procedurally. So I have this empty mesh item here called screw_threading, and I'm just going to add an operator, and I'll add a cylinder. So we have this procedural cylinder, and I'm going to change this a lot. I'm going to go into the properties, and the first thing I'll do is change the axis to X, and then I'll change the radius X to 0, and that just kind of flattens out the cylinder. And then I'm going to change the sides from 24 to 3, so we have more of a triangular shape as opposed to a circular shape. And then I'm going to scale this considerably. So I'll change the radius Y and Z to 4 millimeters. And then I'll just zoom on in, and our small triangle is kind of embedded in the body of the screw. So I can just hit Control 2 to bring up this pie menu, and I'm going to go into wireframe mode. So there we go. Now, this procedural cylinder has handles to move and scale the triangle, but at the moment there's no way to rotate this. So I'm actually going to create a locator, and I'll use that locator to move, scale, and rotate this little triangle. So I'll come up to Add Operator, and I'll type in LOC for locator, and it brings us a transform effector. And the transform effector essentially is just the name of the locator. So I'm going to hit W to move, and I'll just move this down to the bottom of the screw, and this is where we want the screw threading to start. And I'll hit Control Spacebar to go to a right viewport, and I'll just move this over a little bit. I'll hit E for rotate, and I'll hold Control and start rotating this 90 degrees. And the important thing here is to have the flat part of the triangle embedded in the body of the screw, and then the pointed part pointing away from the screw. So I'll hit R for scale, and I'm going to change the action center to local. And the reason I'm going to do that is because if I try to scale now, it's not scaling along the scale handles. It's scaling in world space. So I want to scale it in local space. So now when I scale it, it scales a little bit more intuitively in regards to the triangle itself. So I think that's about good. We can always come back and adjust this a little bit. So I'll hit Control Spacebar and go back to Perspective View. And I'm also going to hit Control and 2 to bring up this pie menu and go back to the default view method. And then I'm going to subdivide this, because right now we have a 3-sided polygon. It's a triangle. And I just want to turn this into quads. So I'm going to add an operator, and I'll type in subdivide, and I'll choose the subdivide mesh operation. And you can see here that it smoothed our triangle, so we lost that triangular shape. So in the subdivide properties, I'm going to change the boundary rules from smooth all to crease all. So now we have our triangle back, but it's composed of 3 quads. So now I'm going to add a curve extrude. I'll add an operator. I'll type in curve extrude, double click that. It asks us for a path, which we don't have. So I'll leave this set to none and I'll hit OK. And it looks like nothing happened. So I'll expose the curve extrude sub operations and I'll expose the tool pipe. And we have a path segment generator and a path generator. Well, I'm going to add a tool pipe because what I really want is a helix generator. So I'll click on add tool pipe and I'll find helix generator right here. I'll double click that. And you can see what happened. It kind of extruded along to make kind of a ring. Now, sometimes what happens is when you create a helix generator, your curve extrude will look like this. Kind of inverted, and there's some weird business going on where the edges are. And that's because the curve extrude, the selection type is set to edge. If you see this, you might be tempted to click on invert polygons because that looks like it kind of inverts the polygons. But what you really want to do is come up to selection type and change that from edge to polygon. So there we go. Now back in the helix generator, let's adjust some of these properties to see what the helix generator actually does. So I'm going to click on count, and then I'll control click on end angle and offset. And then I'm in polygons mode now, but let me come over to items mode and hit C for channel haul. The channel haul only works in items mode. So now if I adjust some of these channels, like the offset, you can see what happens. We're getting this kind of spiral effect. So it almost looks like a spiral staircase or kind of a spiral slide. Now if I adjust the end angle, that changes how many times the spiral wraps around the origin, or in this case, the body of the screw. So if I adjust the count, that actually gives us more segments to support the spiral. So it's like adding resolution. So I know I want this offset to reach the top of the screw, and I want it to end right where the flaring kind of starts, or where it starts. So that looks about right. Maybe a little bit higher. There we go. So the end angle I have to increase significantly. And if I drag, that'll take forever. So let me just do 6,500. And now it looks too jagged, so let me increase the count. I'll do like 250. So that looks okay. Now this threading looks a little bit too... it doesn't look dense enough. So let me actually add some to the end angle. I'll do 7,500. There, that's a little bit, I like the tighter kind of threading. I'll increase the count also to 300 because that can't hurt. So that looks pretty good. I'm tempted to adjust the size of the triangle. So let me come back to this transform effector, and I'm just going to scale this in a little bit on Y and Z. There we go. And let me actually increase just the Z. Okay, so I think I like that a little bit better. So I no longer need this to be procedural any longer. So there's no point in keeping these mesh operations around. So I can freeze this. So I'm going to right click on the topmost mesh item, which in this case is the curve extrude, and then I'm going to click on freeze. So now this mesh item is just a regular polygonal mesh item. It's no longer procedural. So I'm going to toggle the visibility of the screw_main mesh item off so we can just kind of have a look at this threading. If I hit Shift Tab, it gets quite soft. So let's select some edges and we'll bevel them to kind of reinforce the triangular shape or profile which is extruded along the spiral. So I'll come down to the bottom and I'll double click these edges. I'll hit B for bevel, and I have the edge bevel value set to 0.5 millimeter and the edge shape set to square. So if I hit apply and then drop that tool and hit shift tab to go back into Catmull-Clark subdivision mode, we can see that our triangle is kind of maintaining its shape throughout the spiral. So I think that looks good. Now I'm just going to grab this locator and delete it because we no longer need it. That was part of the procedural system that we froze. So now I'm going to have a look at this all together. And before I actually fuse these together with Mesh Fusion, there's one thing that I want to have a look at. And it's this kind of area right here. Where the threading meets the body of the screw, we kind of have this kind of abrupt kind of end. And ideally what I would like to have happen is I'd like to have this threading kind of flow nicely into the screw. Now I'd like to have it happen a little bit more gracefully than just this kind of abrupt kind of effect. So let's have a look at the bottom. I think, yep, it's the same problem here. So let's think of how we can do this. Okay, so one way to control the scale of the top and bottom of this threading is with a radial fall off and a locator. So I'm going to select the screw threading mesh item and I'll add a locator or a transform effector. And if I scale this transform effector in the X and Z, we can see that the threading kind of disappears into the body of the screw. So I'll hit Control Z to undo that. And we're going to modulate the scale with a radial fall off. So I'll expose the fall offs of the transform effector and I'll just add a fall off. I'll choose radial fall off. And this radial fall off comes in pretty big, so I'm going to scale it down so it's roughly the size of the threading. So now if I grab the locator and hit R for scale and then scale in the X and Z, we're actually getting the opposite effect of what I want, but just to show the what's happening. Towards the center of the radial fall off, the scale is very powerful. Towards the end, it's barely scaling. It's not scaling at all, actually. So what we can do is come over to the radial fall off and choose invert. And now the scale is strongest at the boundary of the sphere, and towards the center, it's not affecting the scale at all. So I can also add a solid core, and what that will do is that will cause this gradual fall off to turn more severe. So if I grab the solid core here and then hit C for channel hall and increase the percentage of the solid core, we can see as that solid core grows, the fall off only happens towards the boundary of the fall off sphere. At the bottom here, it's not really having an effect at all. So let's try moving this fall off a little bit. There we go. If I move it up just a little bit, it seems to have an effect. But now the top is kind of poking through a little bit. So what we can do is just grab this locator and scale it a little bit more in the X and Z. We can scale it down quite a bit. So now the top looks great. It's kind of fading nicely into the body of the screw. And then the bottom, let's have a look. Yeah, the bottom looks good as well. Okay, so now I'm going to select my screw underscore threading and hit Shift Tab to get out of Catmull-Clark subdivision mode, because we're actually going to freeze this geometry so that we don't have to rely on the transform effector and the radial fall off. So I'll come up to geometry and I'll choose freeze, and freeze curves as faces, that's fine. I'll hit OK. And now if I select the transform effector and the radial fall off and right click and delete it, we can see that our threading is still kind of merging into the body of the screw nicely. So if I hit Shift Tab, we can go into Catmull Clark mode, and everything looks pretty good. Okay, so now let's start using Mesh Fusion. If I re-enable the visibility of the screw head, these three mesh items are going to be our primary mesh items, meaning they're going to fuse together, and all of our other mesh items are going to cut away or trim these mesh items. So in the Fusion V tab, I'll go up to the top and select New Fusion, and then I'll just give this a name. I'll call it Fuse_Screw, and then I'll click New Fusion with selected meshes. And there we go, that looks pretty good. Now I'm going to come over to the Fusion item, and I'm going to change the mesh mode from Draft to Airtight Final. And that looks pretty good. So now I'll come over to the cross trim and make that visible. And let's go over a few ways in which we can use this as a trim. The most straightforward way would be just to grab this in the viewport, left click, and then drag it onto the item we want to trim. We get this little pop-up. And if I choose Fusion, Apply Subtraction, and let go, two things happen. The most obvious thing is that it actually trims away at this mesh item. But it also turns that mesh item invisible and gives it a magenta wireframe. Now that magenta wireframe indicates that it's a trim, a subtractive trim, and these green wireframes correspond to the green highlight in the mesh, or in the item list, and they're primaries. So that's looking pretty good. I'm going to Control Z to undo that. And let's go over another way we can trim this. If I select the cross trim and then shift select the screw head, which is a primary, and then go down to this first icon in the second row under Set Mesh Roll and Apply, I can click on this icon and it does the same thing. So it's just another way of doing a trim. So if I hit Control Z to undo that, one more way we can set this to trim is just select the cross trim piece, and then in this top row, just click this second icon, which sets the mesh roll to trim. So now we have the invisible mesh item with the magenta wireframe. But as you can see, it's not trimming the screw head. And that's because we only set the roll of this Mesh Fusion item. The roll is trim, but it's not in a relationship with any other mesh items. So in order to put it into a relationship, I can just select this trim, shift select this primary, and then in this third row of Fusion icons, I can choose this leftmost one, which is trim. And when I do that, it actually trims away. Now with both of these selected, I can also select this rightmost icon in this third row. And if I do that, it untrims it. So it's pretty basic, but it's a little bit to get your head around at first. And you might be wondering why you need 3 different ways to do things. Well, this is a basic case of Mesh Fusion, but when things get a little bit more complicated, having all of these extra options is just really great. I mean, it's really, it allows you to create complex Fusion setups really, really easily. So if I hold Control F to bring up the Fusion Pie menu, we can choose this rightmost pie option, which is toggle source visibility. And when I do that, it kind of takes away all of the Fusion source meshes. But we actually have one more that we want to do, and that's intersection. So I'll hit Control F to bring back this pie menu, and I'll toggle the source visibility on, and then I'll toggle the visibility of this sphere trim. And I think what I'm going to do is select this sphere trim, and then in this topmost Fusion icon list, I'll choose this third one, which is set mesh roll to intersect trim. And by doing that, it actually makes this mesh item invisible and gives it a purple wireframe. Now the purple wireframe is a trim, but it's an intersect trim, not a subtractive trim. So if I click on this purple wireframe and then shift click on the screw head and then select trim in the third row, you can see that it trims away at the top of the screw head. It trims away where the two intersect. So now if I hit Control F and toggle the source of visibility, you can see we have a pretty nice shape here. Now, one other feature of Mesh Fusion, which is pretty powerful, is the strip editing functionality. So right now I don't have access to the strips. I have to actually update the strip items to adjust them. So I'm going to click on the Fusion item in the mesh or in the item list, and I'll come down to the Fusion Strips section of the Fusion V tab, and I'll just click Update Strip Items. And once that's done calculating, we'll be able to adjust any of these strips. Now, something else that just happened is our wireframe turned white. And that means we have a hole in the mesh somewhere, and it's likely caused by some of these strips. So I think what I'll do is I'll adjust some strips, or maybe I'll solve this first and then I'll adjust some strips. So we can come over here to More Fusion Controls. I'll click that, and then I'm just going to select Airtight Auto Adjust, and I'll choose Rebuild and Refine, which is the slowest method. And what oftentimes happens is we'll get a little warning which says that it actually can't do the operation, but it actually will do the operation. So we'll see if we get that warning. It did say that it's the slowest, but it's usually not too bad of a wait. So there we go. And that wasn't sped up. So it says this fusion mesh is airtight, so I'll hit OK. And we didn't even get that warning message, so sometimes it happens and sometimes it doesn't. So now I can select this strip and we get the fusion strips pop over, and I can choose this icon right here with the double yellow arrow, and we can see that the strip width is 1 millimeter. I can change that. I'm not going to change it too dramatically because I don't want it to run into the cross trim, so I'll just change that to 1.5 millimeters. And then I might also change the profile, and I can do that with the second icon, with this kind of quarter piece, this quarter green piece. And I'll just change that from 50% down to 10%, and that will make the profile flatter, which I think gives us a little bit more of a mechanical look. And then I'll grab this strip right here, and this one I'll change a little bit more dramatically. Now I can use this icon to change the width, but just to do things a little bit differently, I'll come over here to the fusion strip properties, and it's the same thing. I'm just going to change this to 8 millimeters, and what that will do is increase this strip so that it kind of transitions from the body of the screw to the screw head a little bit more naturally. So now I think this is basically done. We can output the fusion item by coming over here to the fusion item in the item list, and then I can choose, well, first of all, the mesh mode is set to airtight draft. I'm just going to reset that to airtight final. It actually was reset to airtight draft when we ran that close holes operation. So now I'm going to click dupe and convert to mesh, and I'll rename this FO for fusion output underscore screw, and I'll select create mesh. And that mesh is created above the fusion item. So I'll just right click and change the color to none, and I'll pull that beneath the fusion source. So now, just to check to see if this is really airtight, I'll go into polygons mode and select all the polygons by double clicking on it, and then I'm going to hold Control and select edges. And when I hold Control, edges will turn into boundary, and if no edges are selected, it means that we have an airtight mesh. And I don't see any edges, so I think we're good. So I'll go into items mode and I'll select this mesh item, and then I'll hit M for material, and I'll just give this a name of metal underscore 01. I'll change the color to a kind of bluish color. Hit OK. Okay, now let's go to the Layout tab. And I'm already in, looks like, my Chrome settings. If I navigate up to the top of the Material preset browser, we can see that we have all of these folders with material presets. So I can make a plastic screw by coming to the plastic folder, but we're going to do a metal screw. And we have all of these different metals, from aluminum all the way to zinc. So I'll come over to steel, and I'll choose stainless steel brushed. I'm just going to click on that preset and drag it over and drop it on the mesh item. And you can see that it turns black, but when we go to render this, I'll hit the square to render that. I'm sorry, I called that a square, it was a triangle. We can see the results that we're getting. So if I just stop tumbling and let this resolve a little bit, we're getting not a terrible result. Maybe it's a little bit too shiny, but it's not half bad. Now this might not be the most practical way to make a screw, but it's not a bad way. It's a little bit dense, but this was really just a means of showing everyone the new Mesh Fusion and the Helix Generator, which is a great procedural mesh operation introduced in MODO 10.2. So I hope this has been helpful. Thanks for watching, and stay tuned for more videos.
Yum, yum!